my name is Bernhard and today I'm going to show you how you can measure the complex transfer function or the S-parameters of any electronic device with the Bode100. To measure the S-parameters with the Bode100, we simply connect the input of the device under test to the output of the Bode100 and the output of the device under test to the channel 2 of the Bode100. It is important that the channel 2 is terminated with 50 ohms since the Bode100 has a 50 ohm source impedance. I will now measure the scattered parameters of this 25 MHz high-pass filter, which is already connected to the Bode100. Now I need to set up the Bode100 to perform the measurement. To measure the scattered parameters of the device under test, we need to make sure that the Bode100 is set up correctly. We see that our channel 1 is already connected to the source, so we pick up half of the source voltage, and now the output of the device under test is connected to channel 2. And to make sure that we measure the scattered parameter, we need to terminate channel 2 with the 50 ohms termination inside the Bode100. After we have done this, we immediately get a nice curve for our high-pass filter that represents the scattered parameter S21. As a small bonus, if we measure the reflection, we get the scattered parameter S11, which is the reflection coefficient of our device and shows us how nicely the device matches the 50 ohms impedance of the Bode100. If we want to measure the complex transfer function of a device under test where we have no direct access to the input and the output, the complex gain measurement of the Bode100 in the frequency response analyzer mode becomes especially handy, because we can switch our both input channels of the Bode100 to high impedance and then connect oscilloscope probes to pick up the input voltage and the output voltage of the device under test. With these two values, we then can measure the complex gain of the device under test while it is inside the circuitry. Now we will measure the transfer function of this 25 MHz high-pass filter when it is inside the circuitry. We have an attenuator, then we have the filter, and then we have an attenuator again, which is terminated with 50 ohms. We pick up the input voltage of the filter with a probe and lead it to channel 1, and then we pick up the output voltage of the filter, and this is connected to channel 2. And now we will set up the Bode100 to perform the measurement. To measure the transfer function of our filter while it is in the circuitry, we need to make sure that the input voltage of the filter is connected to channel 1, which is connected to receiver 1, and that we switch the channel 1 to the high impedance mode since we are using an oscilloscope probe. The same applies to channel 2. Now we are ready to measure. We start our measurement and we can immediately see the frequency response of our filter. In the area of the cutoff frequency, we see a small elevation. This is caused by the fact that now the input voltage of our filter is taken into consideration for the transfer function calculation and not the source voltage of the Bode100. Measuring S-parameters and the complex gain is no longer a secret to you, but there are a lot more possibilities how you can utilize the Bode100 for your application. Check them out at www.omicron-lab.com.